Hi, I am Marimuthu from RMK Engineering College. In this video, I am going to explain about the implementation of Arduino based line follower robot using MATLAB. Okay. So before start with the line follower project, just I explain the installation method about support packages of MATLAB. So then first everyone must understand what is meant by support package. So the support packages is nothing but interfacing the hardware with MATLAB. So there is a special software is available with the MATLAB website. So here you can install that MATLAB support packages by clicking this add-on here. So in this MATLAB software, this is a MATLAB 2018A I have installed. Okay, so in the software, so you can click this add-on, so you can get this get hardware support package. So once you click this once, you can get the new window. Okay, so this is a new window here. So in this new window, you can see various hardware support packages available for the real-time implementation projects. Okay, so in these projects I have used some of the hardware. Okay, so here for example, it is in the green. So that means I installed these support packages in this system. Okay, so like this one, I used some other software also. So this one is a embedded coder support package for the Texas Instruments. So this is for the research work. Okay, here, so another one is, so this is a Simulink support package for the Android devices. So using this software, we can connect all the mobile phone with the MATLAB. So we can utilize the sensors which is present in the mobile phones, Android mobile phones. We can connect with the MATLAB and we can use for the project purpose or research work also. Okay. So some other example I will show that one. So here various type of support packages will be available for the same hardware. Okay, so that is based on the version. So the number of versions will be available. For example, so MATLAB 2014A will support for some other packages. So that for that they have to use particular support packages. So this is for that webcam. So this support package is for interfacing the MATLAB with the webcam. Okay, then you can see here it is a this is a support packages for that Raspberry Pi. So Raspberry Pi everyone knows. So we are using for the various project IoT projects. So we can use this one for the Raspberry Pi with MATLAB. So likewise, okay, here also. So here you must understand the support packages can be released by the anyone, even the community people. For example, the MathWorks community also they can release. For example, those who are having the interest in the writing the MATLAB support package software, they can also upload in the MathWorks Center library. So here you can see that one difference. So the MathWorks, so the Math one, the first one which is released by the MathWorks staff members. Okay, so the most of the things it is a 181. The remaining is released by the MathWorks package programmers. So they can also publish for that their own support packages. So various type of support packages will be available in this MathWorks website. Okay, so here it is an example for the data acquisition toolbox for the National Instruments software hardwares. Okay, so like various types you can see that one. Instrument control toolbox. It is a keysight. So it is a keysight. It is a I think a DSO. I think you know that one. It is a DSO libraries. And so for some other application, it is for that processor. This processor, ST microelectronics processor. Then it is for that IO devices. That is Apple IO devices. Okay, so this can be connected with the MathWorks. Okay, this is another one is a AutoSAR. So AutoSAR is used for the generating the model and design and implement the automotive industry model based design. Nowadays, the most of the electric vehicle controller has been designed using the AutoSAR. For here you can see that develop the AutoSAR software components for automotive systems. Here this is the image acquisition toolbox. Then so various. Okay, so yeah, various hardware can be interfacing with the MathWorks using these support packages. Because while we install the MathWorks software, so there is most of the hardware cannot be directly interconnect with the MATLAB. Using this support package only, we can connect with the MATLAB and we can go for some other real-time applications. So now I will explain one example from the MathWorks example. Okay. Here I can take this example. Okay. So this example is given by the MathWorks in the central library, as well as the once you install the support package software, so automatically it will be loaded in your computers. So we can use for our applications. We can modify the model and for our own applications. It is a copyright of MathWorks, so we can get using the license also. Okay. So here this is a simple closed loop system for the Arduino robot line follower applications. So everyone knows that line follower concept. So the line follower is nothing but, so based on the IR sensors, it will follow the line which is drawn on that park, that is a parking area or some other place. Okay. So what is the concept is here? Okay, the concept is IR sensors will find out the sensor deviations. So whether the line is followed by the robot or not. So then how much percentage it is deviate from the line which is drawn for the movement. Okay. So based on the sensor movement, based on the sensor, the error will be calculated using the error detector. So this is the error detector. Then this is the desired deviations. How much deviations can be allowable to the run the robot. Okay. So based on the error, what can we find? We can find out the error direction as well as the deviations. So the error direction is used for the directions. So simple, very simple concept. If the error is positive, it is in the one direction. If the error is negative, it is in the opposite direction. So based on the polarity of the error, it can be detected. That is a torque directions. So another one is a controller. So this controller is used to drive the motor. So what is the need of the PID controllers? The PID controller is used to run the motor with a steady state error and the transient error. Okay, based on the controller performance, the motor can be smoothly running on the track. Okay, it is a simple PID controllers. We can use we can set the parameters based on the design. Okay, the design can be it is a trial and method, and some other basic methods are available. Zeiger-Nicholas, and a lot of methods are available for finding the PID values. So here also some auto tuning methods are available. Okay, so by clicking these ones, it can be automatically select the PID values. Okay, next we can move to the algorithm. So this is the algorithm block. Okay, so here is it is a sensors. Okay, so this is a sensors, it is a motors. Okay, so how we can use this motor can be connected with the Arduino. Okay, so the same as here, how the sensors can be connected with the Arduino. So here you can click it here. So here the sensors, all the sensors are connected here using the Arduino hardware part. Okay, so this indicates these are all the Arduino sensors can be connected using this block. Okay, then we go for the output side. So output side, it is a motor driver. Okay, so this motor driver, it is the output of the Arduino. This output can be drive the motor driver. Okay, so the motor driver is a separate part. Okay, so that can be connected with the motor, because the Arduino is directly cannot drive the motor. So these signals only trigger the particular driver, then the particular motor will be running. Okay. So then I will show some example how the algorithm has been implemented. Okay, so this is the part has been the algorithm has been implemented here. Okay, see here for the algorithm implementations, what are the things are needed? The torque directions and the torque corrections. Then the bias torque. The bias torque is the minimum tolerable, how much we can fix it. Okay, so that is these three inputs decide the output of the motor. Okay, so the output, how the which motor has to be turned on, which motor has to be turned off, that is decided by these three variables. Okay, so one is constant, the remaining two are variable from the sensors. Okay, so this algorithm, okay, so very easily you can understand. For example, so the torque direction is greater than 0, so then this goes track to turn right. Okay, so that's same as here. If the torque direction is less than 0, so goes to the turn left. Okay, so this is a normal concept we can write by the small coding. Okay, everything is designed by the MATLAB only. Okay, just I will explain the how it can be working for the robotic software. Okay, so this algorithm will produce the commands. So these commands will be given to the motors. Okay, so this block for the sensors. Okay, so now we move to the motor sections. So here, so the two commands coming from the algorithm. So one is for the left side, one is for right side. Okay, so here this is a small relays. So this relay is a controlled relay. So for example, the middle point. So the middle point is a control signals. So based on the control signal, the switch can be transferred from one point to another one. For example, normally it is closed with this point. Okay, so when the signal is coming, okay, when if it is verify the signals, so then it will be failed to get the control signals less than or greater than, automatically move to the another positions. So based on the control signals, it will be working. Otherwise, it's normally closed on this direction. So this is a basic concept of this relay. It is a normally closed and open contact line. Okay, so then, so these signals will be taken from here. It is a common signal for the reverse and forwards of the left side motor. Okay, now it is directly given here. So then it is mixed with the 0 signals. Okay, what is the use of this one? So this signal is for this motor. That is the interlock conditions. So if this motor is running, this motor should not run. For that, so this 0 is given here. Okay, so if it is high, so then it is 0. So both will be flowing through the signals. Then it is in this motor, the pin 6 number motor will be running, it will be turned off due to the 0. So if the direction is detected in the negative directions, for example less than 0, okay, what will happen? So this signal will be coming here. So this is a modulus. Whatever the input is coming, so it will be converted as a positive signal. So now it is high, at the same time this is 0. Okay, so then it will be given to here. So now automatically this control signal change the polarity to here. So what will happen? This point to here now. So now this signal will be flowing through this. So this motor will be turned off, then this motor will be turned on. Okay, this same concept can be used for here in the right side motor also. So then this is the PWM output. So this PWM output is used for to varying the motor speed. Okay, so based on the PWM width, the motor can be adjusted. So how it is working? I will open one block here. You can see this. So it is a Arduino PWM output. So this block accepts 0 to 255. So when the PWM output is maximum for 255 and 0 is mentioned as minimum. Okay, so that is based on the duty cycle. So 0 is for 0% duty cycle and 255 for maximum, that is a 100% duty cycle. So that is a maximum running speed. If you want to reduce the speed of the motor, we can reduce the duty cycle. So the automatically particular motor will be reduced. Okay, the speed of the motor is reduced. Okay, so this is a basic concept of these ones. Okay, so this example can be downloaded from the MATLAB expert. Okay, and also the support package software also. Okay, now I will explain how to implement this project into the hardware. Okay. Okay, so once you install the support package software, automatically this the supporting hardware implementations part will be also installed. For example, I will tell that. So once you open this model, you have to click this model configuration parameters. Okay. So here it is in the hardware implementations. The hardware board, this board is I have connected, so it is selected here. Otherwise, so the default board will be, that is a Arduino robot motor board. It is available in the market. So directly you can purchase, then you can download this algorithm into the board. Otherwise, you can use any Arduino board for implementing these applications. So then it is a device details. Okay. So this here, okay, this is not needed. Okay. So here, what is the meaning of this ones? Build, load and run. So once you click these ones, automatically once the MATLAB software develop the code, automatically the particular code will be running on the hardware. Otherwise, sometimes we need only the code only generated is enough. Then we can click build. Otherwise, you click build, load and run. Okay. Then another important things, how we have to connect the hardware with the MATLAB. So here there are two options. So one is automatically, otherwise manually. So how we can find out the manually? So we can click that computer management. So everyone knows this, how to select this software and these options. Okay, here in the port you can select the Arduino Mega 2560. It is connected in the COM3. Okay, so it is mentioned as a COM3. Then you click OK. Now here you can see that one, to run this model on the hardware, click the deploy to hardware button. This model run as a standalone application independently. So that is the meaning. So once you download these applications into the hardware, after that we don't want to use that MATLAB for the applications. Yes, it is the particular product can be now, it is a standalone applications. So it is possible. Okay, I will tell that procedure here. So the deploy to hardware button, it is a deploy to hardware button. Okay, so you click it. So wait for some time. Yes, it will take 1 or 2 minutes sometimes. Okay, so now already I have run this code, so it is immediately it display the output. You can see the result here. So build process completely. Okay. Okay, so you can see the code also, the code, how the code is generated. Okay, so this is a code generation report. The corresponding code is like this one. This is the corresponding code for the applications. So this code has been generated automatically. We don't want to write the code for these applications. Okay, automatically the MATLAB has been generated the code. So this code also directly loaded into the particular hardware. Okay, now the Arduino board is ready for the line follower applications with some other hardware circuits. So like sensor and the motor driver. Okay. Okay, thank you for watching this video.